Okay, here we go. Good afternoon. Welcome to the webinar on para and polyfluoroalkyl substances, or PFAS, also known as the forever chemicals. I'm Dale Medeiros, and I work as a senior regional planner for the Northern Virginia Regional Commission, the NVRC. We're a regional council of governments representing the 13 counties, cities, and towns, and the 2.6 million people of the Northern Virginia region. We got to this webinar today because PFAS are man-made synthetic compounds. They were produced in the 1940s to make products resistant to water, stains, heat, and studies have indicated that exposure to PFAS has been linked to human health issues and concerns, including cancer, liver damage, and immune system effects. It's estimated there are about 15,000 different types of PFAS in different commercial applications. Given the ubiquity and the persistence of PFAS, the planning, the detection, treatment, and remediation of PFAS in water systems presents a unique set of economic, human health, and ecological challenges for the region's watershed, also water infrastructure. Across the Atlantic, EU countries such as Germany face similar challenges among their regional water systems with the detection, treatment, and remediation of PFAS. And this month, the EU unveiled its PFAS strategy to implement drinking water limits for 20 specific PFAS and 4 other key compounds in 2028. The strategy calls for mandatory monitoring, investing in advanced treatment technologies like activated carbon filters, and an interministerial action plan aimed at reducing industrial emissions. So in light of these shared challenges across the pond, we've invited Andreas Kraemer, the founder and director of Emeritus of Ecologic Institute, Berlin, Germany, to share with us case studies from the regional level in Germany and Europe, where practical solutions have been developed and applied. A little bit about my friend Andreas. Andreas is an environmental engineer with a degree from the Technical University of Berlin and a lifelong think tanker who's focused on the integration of environmental and sustainability concerns into other policies. Andreas is perhaps best known as the founder and director emeritus of Ecological Institute, where he still contributes and works. He's now chairman of the Agora think tanks and inaugural chairman of the oversight board of Rise Up for the Ocean. Andreas also serves as a special advisor to the board of directors of the Ocean Azul Foundation. And for 3 decades, he was co-chairman of the investment committee of the Ecovision fund, Eco World, with about 2.5 billion euros in assets under management. Andreas has also taught European integration and environmental policy as a visiting assistant professor of political science and adjunct professor of German studies at Duke University. I've also had the privilege of knowing and working with Andreas for almost 33 years. Just a little bit of housekeeping. After Andreas shares with us his work and the case studies in the slide deck, we want to engage all the participants as much as possible. So I invite you, please put into the Q&A box any questions that you've got, and at the end of the presentation, we'll run through them chronologically. Thank you so much, Andreas. Please take it away.
Great, thank you. You can hear me, you can see my slides, everything
Just
is okay.
perfectly.
Yeah.
Perfectly.
Thank you, Dale, for the introduction. Very generous. You made me blush. Flattery will get you anywhere. Yes, I've been invited to contribute some of the European thinking and some case studies on PFAS, and I'm happy to do that. It is actually something that I've been working on for many years. I first started working on the chlorine chemistry, as we call it in Germany, or halogenated organic chemistry in the 1980s, when we were regulating, when the regulatory focus shifted from the chlorinated substances, chlorinated hydrocarbons, CHCs, to the partly fluorinated CFC substances. And I was involved in policy analysis, policy learning in the European Union. And essentially the story continues. This is just the latest chapter in a long-running soap opera of a battle between the chemical industry and regulators all around the world about what to do with those substances, how to regulate them, how to test them, how to follow their course through the environment, and how to protect human health, environmental health, and so on. So the purpose is here today to look a little bit at this whole problem, what PFAS are. I guess most of you know what PFAS are and what they do to us and what they do to the environment. Otherwise, you wouldn't be here. But I will give a brief overview of some of the key concepts which I think sometimes are missed in the discussion. And the first point is to say that PFAS pollution is ubiquitous on this map here. You see the hotspots within Germany, and you can actually, when you know the geography, detect the river systems, the conurbations, the densely populated areas. You can see the river systems where we have the chemical industry. That's the Rhine that you see as the sort of the red sausage. And in the north, near Hamburg, near the North Sea, you do see the River Elbe and the concentration of chemical industries around the seaport of Hamburg. So I thought that I'll look a little bit at the chemistry. I will skip over the history and the production and the use, because I guess that is fairly well known, and it was actually part of Dale's introduction. Health and environment, I will skip. I will look at the regulatory status. I will look at what it means for water supply. I have a case study for you from the area of Rastatt in Germany, and another one from Flanders, the northern part of Belgium. I will put a focus on TFA, which is one of the substances. It's actually the smallest one of the PFAS substances, and therefore presents a specific problem for water suppliers. And finally, I then will look a little bit at what the EU is developing and what you can expect to come up in the future. Now, in principle, all the PFAS follow a fairly similar structure. They are essentially a long sausage, which you see on the left here, fluorinated throughout. So from the outside, it is negatively charged, and the inside is positively charged, but it's basically non-polar. There is a little bit of a polar bit at the right-hand end, which gives it its chemical characteristics. And basically, the polar group, the one at the right-hand end, that can be different, and depending on what exactly that is, which acid it is, the PFAS has a different name, and the tube on the other side, on the left-hand side of the picture, can have a different length. TFA only has one C connected to fluorine, but others are much longer. So in principle, that is what they look like. And because of that characteristic, having a long sausage type structure that is non-polar, and then having a polar end, PFAS love to be at the borderline between oil and water, or air and water, which is, Jessica, you're here in the call, which is why you find the highest concentration in the natural environment actually in sea foam, which is a complicated matrix where you have lots and lots of surface, where on the one side you have water, on the other side you have air, and that is where the PFAS that is normally in the seawater will accumulate with concentration factors of more than 1,000, more than 10,000 in some cases. Absolutely astonishing how well that works in order to concentrate PFAS in the system. Dale already said that there are more than 15,000. Some people say there are 16,000. About 200 of them are produced on purpose, and the rest comes on with the wash. And then they are found in various mixtures. And I think this is one of the important things to understand, is that the PFAS are a complicated and very large family of compounds. In many respects, the family members are very similar, or the branches of the family are very similar, but they do also have some differences that may be important in some instances, and many are not. We only pay attention to a very small part of the total thing. So if you think of it, the yellow tip of the iceberg, that is where we pay attention to PFAS, specifically the ones that are here. But you see from the alphabet soup of abbreviations, there are many more. And in many cases, we don't actually know where they are, how they are. We have no chemical protocols in order to identify them, in order to measure their concentrations, in order to follow them through the environment. So a lot of this is actually unknown to us, and yet we have to regulate it. When you look at the chemical industry, in this case, industrial organic chemistry of PFAS, then it's important to understand a few concepts. One is coupled production. In many chemical processes, you produce one thing, and automatically in the production, something else comes out of the same reaction in fixed quantities, in variable quantities, in unknown quantities, in quantities that fluctuate throughout the process. And as a consequence, very often you have isomers, meaning things that have the same sum of sort of the chemical sum of atoms in the molecule is the same, but the structure is slightly different. So they weigh the same, they look the same in many ways, but they can have different qualities because they have the different structure. And for the chemical industry, that is a problem because in many cases, you don't want those isomers, or you're not clear what is in a mixture. And then one of the things that the chemical industry needs to do in order to reduce the risk of handling those substances is to homogenize them, to make them indistinguishable from one another, so that within a mixture, it's all the same or all so similar that this distinction is no longer necessary or even possible. And the classic ways to do that are the chlorination, meaning you replace ideally every hydrogen atom in a carbon chain with chlorine on the outset, or you do it with fluorine, or you do it with a mixture, and then you call it halogenation. And this is really a way of the chemical industry to process unknown wastes. Mixtures of unknown wastes can be homogenized by that process, and then suddenly you have a mixture of substances that are more homogenized. You know their properties much better. You can handle them in that way much better. And then the gain of the chemical industry is to take that chemical waste and declare it a product for some sort of purposes. That is originally where it started with the creation of polyvinyl chloride, PVC, in the 1920s, I guess, which was really a response to having surplus chlorine and surplus, what's it called, ethene, acetylene in English, and combining the two things into something that could then be stabilized by the addition of additional substances was actually a possibility of making a useful product out of something that would have been a hazardous industrial waste otherwise. The last concept I wanted to stress on is that in Europe, the regulators have been seduced into adopting a single substance regulatory approach. So in Europe, in most cases, we regulate substances substance by substance. For each substance, there need to be tests, there need to be an assessment, and then it can be regulated, which if you have 15,000 or 16,000 substances just in the PFAS family, it just takes forever. So in my presentation, I always put the links, the URL links to the documents where you can find more detail if that is what you would like to do. And the first thing I wanted to do is take you to Germany to a case study in Rastatt. Rastatt is a small town near the Rhine. You go to the Rhine, you cross the Rhine, and you're in France, in Alsace, where you have beautiful food and beautiful wine. And the area is actually very rich. Nearby Baden-Baden has one of the highest concentrations of visiting millionaires, if not resident millionaires. And this is one of the places where we have it's the place where we have probably the most important instance of PFAS contamination in Germany. And it happened that over a long period of time, a local paper manufacturer produced paper that was coated with PFAS for the reasons that Dale explained, make it grease-proof, make it waterproof, that sort of thing. And the production waste was then given to a local composting company. It mixed it with other green waste, composted it, and then sold the compost to local farmers and elsewhere in the market. So it was applied on agricultural land and elsewhere, which then resulted in a slow contamination of the soil, of the groundwater, until it was detected in drinking water wells. And so things had to happen. And that actually then led to what is now the best known and best research case of PFAS contamination in Germany. The area might look small by American standards, but it is a large area when you consider the number of people living there, depending on the water supply from the area. And in Germany, most municipalities have their water supply from the local groundwater source. It's only where groundwater is not available will Germans go to either interconnection or to the use of local surface water. But the preference is always to take the groundwater where it is available. The area affected is quite large. The PFAS plume in the groundwater is now quite large as well. It generally flows, as plumes do, from the area, from the upland area, the watershed areas down towards the draining rivers, in this case, the Rhine. And you can see the numbers. These are the highest, very high concentrations, and it forced the shutting down of drinking water wells. So the impact at the moment is that many public wells are fitted with activated carbon treatment in order to reduce the pollution at the well level. In some cases, that was not sufficient, so additional wells had to be drilled in areas outside of the plume. How long that will be useful is another matter. Agriculture has restrictions on the cultivation of sensitive crops and is no longer allowed to use groundwater for irrigation, which in fact means no irrigation anymore. Farmers will not pay prices from the public water supply for irrigation water, except in extraordinary circumstances, perennial crops, perhaps. And there are other things that Germany or the local and regional authorities are doing here. There are a number of measures that have been adopted, and I've listed them here, and you can read much faster than I could take you through them. But essentially what is happening is that this is the area where the concentration of PFAS pollution was highest, where we still have a tradition of local water supply. The area is rich enough for the authorities to have the money in order to address these issues. The area also has the capacity, the scientific capacity to solve problems, to understand the challenges and to solve problems. And that is why this is, I believe, an interesting case study. At least it is the one that in Germany most people look at. The key lessons that we can learn from that one is PFAS are not only persistent, that was known, but they're also very mobile. They are highly mobile in groundwater systems. That is something that perhaps people who knew the chemical properties knew, but the farmers and the industry didn't know, or at least they pretended not to know. We also know now that even though PFAS are an industrial pollution case, and the second case study focuses on that, in this case, the mechanism went through the diffuse sources through the application of compost on large pieces of land, and that resulted in the mobilization of the PFAS into the groundwater. If you want to solve the problem, you need a long-term solution. You need to implement it over a longer period of time. It will take decades, if anything, to manage the plume and to clean up the contaminated groundwater, if that is at all possible. Germany is generally a water-rich country. We do have some areas that are semi-arid or even arid, but when we look at water quality, we also feel that Germany is becoming a more water-stressed area. Now, the advice to agriculture, and this is something that is new because in Rastatt was the first case where actually restrictions were imposed on the farming community. So it completely changed the dialogue within Germany. Suddenly, PFAS were a problem that farmers were forced to understood, and it went from one farming community in one place towards the farming associations, their lobbyists, and now we have them elsewhere. So it is really important to understand what the implications of such PFAS contaminations is for farmers. And the advice for them is to switch away from crops that accumulate PFAS more easily towards crops that do not do that. And when you read through that, you understand that it actually means moving towards lower value crops. And in some cases, just forage grasses, you don't get the same amount of money for feedstock than if you produce food for humans. And you still get even less if you are reduced to producing energy crops, where contaminants that affect human health are not a priority. So those are the things that the farmers had to learn here. Some of the waterworks had to invest quite a lot, and there is now a court case going on. Actually, it is concluded in the sense that the court ruled in April of this year. It was a major victory for the Stadtwerke Rastatt. That is the local water supply company. It took them 7 years to get there. And basically, the judges found that the composting company, the waste management company, an intermediary between the paper mill and the farmers that were buying the compost, they are the ones that are liable for the PFAS contamination, because they would have known, they should have known. And even though liability is established, the compensation still has to be determined. I don't think that will happen because the waste management company is essentially bankrupt. And there is no point, you can't squeeze any compensation out of a company that is already bankrupt. In essence, it resulted in the local water supply company owning the waste management company. They don't own it in the proper legal term, but either they push it into bankruptcy by pushing for compensation, or they let it run in the hope that some of the dividends may actually pay for the remediation. So in essence, they can control the future of this waste management company, which was not their original intention, which is not their specialization. So I don't know what will happen. I've had no idea what happened to the appeal. I'm sorry about that one. That's the end of my case study on Germany. And this guy just tells you we go west towards Belgium for the next case study, which is in Zwijndrecht, which is near near Antwerp, the port city of Antwerp, and it's in Flanders, so it's the northern part of Belgium towards the coast. It is an interesting case because it's actually an industrial production case. It is from the 3M Minnesota Mining and Manufacturing site that is one of the largest producers of PFAS and other chemicals in that part of the world. It is a long-lasting case, and it is ongoing legal action at the moment. They operated the factory there since the 1970s, and they were producing lots of lovely stuff like firefighting foam, stain-resistant coatings, and other industrial applications. And it was really by coincidence that they were excavating the ground in order to build a new canal or for highway project with a bridge. I can't remember exactly what it was, but that is where they suddenly found out that there is contaminated soil. And they were surprised that there was contamination outside of the factory site itself, so outside of the perimeter fence, which, of course, if you understand the chemicals and the solubility and the mobility of PFAS, you would anticipate, but neither industry nor regulator had, in fact, anticipated it. So people were a little bit surprised. They did a massive investigation of PFAS in levels in blood and found very clear correlation. The closer people lived to the 3M facility, the higher the contamination or the concentration was in their bloods. And in some cases, they had levels that are usually associated with medical conditions. And all of this created a lot of media coverage and subsequent political pressure. And that always happens in environmental policy when you see a combination, a confluence of human health concerns and environmental concerns. That is when political action actually becomes relatively easy. So 3M then committed to contributing a considerable amount of money, almost, well, I guess it's 650 million US dollars for remediation. The Flemish government is not happy with that. They want to have more. And you can see what they want to spend the money on, including a PFAS environmental fund in order to have money set aside for the future expenses that they can anticipate now. It is anticipated that this will be a decade-long remediation effort if remediation can actually be achieved, and that it will be the management of the contaminated plume in a similar way that has also been developed in Rastatt. Behind that is the idea that you understand the plume, you understand the hydrological flow dynamics in the underground, and you pump the contaminated water out and thereby try to stop the plume from spreading further. And hopefully you can that way contain the problem in any case. Since February of this year, we do have a criminal trial related to this pollution incident. There is a civil litigation going on for compensation, and there is a criminal trial trying to establish tort, criminal liability, criminal guilt in that sense. And we don't actually have that many cases where criminal law is applied to companies or the officers in companies in Europe. That is something that is more common in the US. And so this is the first prosecution of a PFAS manufacturer, meaning the company in Europe. And yes, you see that the judges will have to look into a lot of detail in order to establish and apportion blame and responsibility, and whether or not it will result in a criminal conviction remains to be seen. But the civil litigation goes in parallel anyway, and either way, it's going to create precedents in the European system. So that is a little bit the second case study from Flanders. And now I wanted to look a little bit at trifluoroacetic acid, TFA, which is the smallest PFA that there is. So it only has two C molecules. One has 3 fluorines around it, on the other one has an oxygen atom sitting there, and then there is an oxygen-hydrogen group sitting there. So those who remember their chemistry lessons can imagine what it looks like. It is the shortest, the smallest molecule, which then means that it's also highly mobile, and it is really hard to get out of water. It is highly persistent as well, and it has a lot of origins, including in pesticides. So it ends up not only in factory applications, but also is applied directly to the land. And we now find it ubiquitously all around the globe, everywhere. We find it in precipitation, and when the water falls onto the ground, it will infiltrate into the groundwater, and we will find it in drinking water, and we can predict when the concentrations in drinking water will be so high that the drinking water is then technically no longer drinkable. These are globally the concentrations in nanograms per liter of TFA in atmospheric deposition, meaning rain for most of us most of the time. So you can truly see it's a global problem. In Germany, it looks like this. The light blue is where the TFA contamination comes predominantly from the rain. That is the very rainy areas along the Alps in the south and in the west, where the prevailing western winds hit some foothills, and along the coast where you have a similar dynamic. The green is agriculture, and you basically have it everywhere. And the few red dots that we have there, the industrial sites. So TFA is something where the agricultural sector is a victim, but it's also part of the problem in that they use the substances in a number of for a number of purposes, and so therefore they pollute their own groundwater source in that way. Why is TFA a drinking water challenge? Because it is persistent, highly mobile, and it will go into the groundwater, it will go into the drinking water, and if it is there, it's practically impossible to get out. Even with reverse osmosis or with activated carbon treatment, you can't get it out. So what to do about that? We don't actually know. The water suppliers in Germany, they all say, look, for a while we can keep going. We can go for the least polluted groundwater sources. We can do interconnections in our supply systems. But we know, we can predict, because all the TFA that is already in the atmosphere, and even if we stopped emitting it today, it would still continue to rain down, and we can predict. So this is a problem that is unavoidable in a way. Now, for something very different, and this is a new concept that has been developed by German and Norwegian regulators, essentially, regulators and scientists, some of them from universities and some of them from regulatory authorities, environmental regulators. And basically, they looked at the PFAS and they said, well, our traditional ways of capturing the hazardousness of substances doesn't really do justice to these because they are persistent, mobile, and toxic, PMT, and they're also very persistent and very mobile. So they shift the focus towards persistency and mobility, plus the concern that they could also potentially be toxic or are toxic in some cases, but escaping the need to prove bioaccumulation. That is the purpose that they have. And basically what they say is these substances, because of the characteristics they have, they can be treated as a class, and you can use this persistent, mobile, and toxic, and then very persistent and very mobile concept to characterize chemicals in order to regulate PFAS much more quickly. It enables grouping. You focus on the intrinsic properties rather than trying to prove ex post all the impact on biological systems that in other cases you would have to do. So it makes the whole process of regulating PFAS much simpler, and it allows more precautionary regulation than previously has been possible. It's really a challenge, a new approach and a challenge to the European regulators, who in chemicals always looked at substance by substance and always looked for evidence, sound scientific evidence of toxicity and tendency to bioaccumulate before they regulated substances. Here they say, no, we only have to show that the stuff is persistent and mobile, then we know it will go through, and therefore we have justification for regulating under Europe's precautionary principle. Coming to regulation in Europe, there is a lovely timeline that has just been published 2 weeks ago or something by Nigel Haig, long-time director of the Institute for European Environmental Policy in London and in Brussels. And he basically looked from a UK perspective at the history of PFAS regulation, and basically says it's another case of where we knew relatively much. We knew enough early on in order to regulate, and yet we didn't. And today we have those regrets. And in that sense, he regards it as a case study. But rather than looking back, let's look at the future, what will happen next. Dale already said there are regulations about monitoring PFAS in drinking water. That is something new, but there is also a new assessment of the regulatory, the need to regulate PFAS and TFA in specific by the European Chemical Agency and its regulatory, risk assessment committee. And as a result, we now have in place all the necessary foundation stones for the EU to adopt more stringent regulations to regulate PFAS and TFA. So what will happen there is there's a proposal already on the table. A proposal doesn't become law overnight. It takes quite some time, but we already know the regulatory philosophy and the main approaches that are going to be used. One is relatively rapid bans on single use, but also other consumer products, especially where alternatives already exist. There will be sector-specific, industry sector-specific transition periods where there are substitutes that are not really available for practical use yet. So in those cases, there is an anticipation that as soon as substitution is possible, then there will be a phase out of the use of PFAS in industrial applications. So there will only be temporary derogations from what is perceived to be a complete ban of PFAS to the extent that that is possible. And wherever PFAS are used, there's going to be additional requirements going to be put in place, PFAS management plans, which is something that the chemical industry has for so many substances. So it's nothing new, but for the users of PFAS, that will be an additional burden that they will have to report. And there needs to be more reporting and more communication along the supply chain. So what we see now is a pragmatic approach that protects the essential uses for as long as there are no substitutes, and works with traditional exemptions just for a while. And you see the summary of what I expect, what others expect, the total list of sectors that are asking for, pushing for transitional exemptions is much longer than this year. Every industry lobbyist is now pushing to be included in this list of exemptions. I don't think, given the political climate around PFAS, that it will be easy for them. Drinking water protection, drinking water quality will become a stronger regulatory driver. This is because the European Union has a history of regulating drinking water supply and forcing member states to improve their processes. And there is already quite a lot that has been established. As we've seen, once the PFAS pollution has happened, it's really difficult to deal with it. So it focuses more on preventing contamination at industrial sites, but also at diffuse sites where PFAS-containing substances or products may be used. So what we see is a new approach in regulating a number of substances where PFAS is sort of the door opener. Because of the urgent need of regulating PFAS now and the difficulty of doing it with a traditional European chemicals policy, there are now being new approaches being used, new concepts to justify regulation, but also then different approaches to doing the actual regulation, shifting from single substance to regulating whole groups. And that is going to stay with us and go to other areas. And just don't believe it all from me. If you listen to the European Chemical Agency, ECHA, they have just put out very recently an overview report on what they see, where the risks are, what they regard as necessary, sufficient, or not insufficient in regulatory practice, and what they recommend should be done in the future. They recommend 8 additional sectors. I listed 5 earlier on. There will be more sectors asking for restrictions. So that is one of the battle lines. So that is what I wanted to share with you before we now get into questions and answers and hopefully discussion. Thank you very much.
That's fantastic. Thank you so much, Andreas. I think right now the thing that's burning at the top of my tongue is given the prevalence, ubiquitousness, and the persistence of PFAS, and the very, very dynamic, I'm sensing policy developments taking place at the European level and also at the national level. If you had the attention of the Lord Mayor of Rastatt and his environmental and his planning staff, what would you tell them to do, particularly for the short term? Because this is a super serious issue, but I felt overwhelmed at times. But what's the role for local and regional authorities in Europe? And then what might you be able to extrapolate in terms of a lesson for some of the things that we might be picking up on this side of the pond?
Yeah, sort of the municipalities, but it's the mayor or the director of the water supply company in Rastatt. We should regard them as victims. They didn't do this. They didn't cause this. It was caused by others, and they are the ones who, on behalf of the citizens in the town or in the water supply area, they have to somehow solve the problem. And first thing is to make sure that the drinking water that they pump into the distribution system is good enough for humans to consume, which means that the PFAS levels have to be brought down as much as is possible. And in some cases, with a longer chain PFAS, you can do that with activated carbon. That is the choice that they've made. And it's I think, the choice that people will make across the board because of the higher cost of operating reverse osmosis. But if you have TFA as a problem in your drinking water supply system, then even activated carbon doesn't help. Then you really need to go into areas where you find uncontaminated water, drill new wells, or you have to ask the neighboring municipality to ship you in. So that's, as sad as it is, the only short-term thing that you can do. and make sure that you don't apply any more contaminated waste onto agricultural land, municipal parks, or anything like that. Just make sure that the contaminated stuff is treated as it is, as hazardous waste, which probably means that it has to go into specialized incinerators, which is very expensive. And if it had been done by the paper company from the beginning, the paper company might have shut down a lot earlier, or it would have chosen a different way of coating its paper to give it the properties that they got with PFAS. So I think, Dale, as sorry as this is, but PFAS is one of those cases where once the pollution is there, there's very little you can do in the short run to remediate the situation. It is a decade-long application of therapy to the groundwater reservoirs that you need to somehow get in. Their attempt in Rastatt to send the bill to those people who were responsible, in this case, the waste management company, didn't produce any effects. It just meant that the company went bankrupt, and the legal bill, as well as the cost on the substance of dealing with the problem, still remains on the shoulders of the municipality. So even there, it doesn't work. This is a textbook example of how the profits from the paper company and the profits from the waste management company were privatized, and all the problems associated with their practices were put onto the shoulders of communities in which they operated. But that is what our legal system allows.
Does that feel like the similar situation for those, given the differences in water sources, groundwater and surface water? Is that basically the same situation that American local governments and regional governments face with this issue?
Well, it depends on the type of water supply system that you have. In theory, a water supply system that relies on surface water, you would expect sort of fresh rain falling in the upland areas, and then eventually sort of the river brings fresh water that is not contaminated down. It doesn't work if you have atmospheric deposition. If the rain is already contaminated, then the river water will remain contaminated. And it doesn't work if your sediments are contaminated. But the sort of the memory of pollution of a river is shorter because the river flows away, and in groundwater it is much longer. However, on PFAS, many of the PFAS do not actually adhere to the solid matter in the soil, neither the organic nor the inorganic matter. So it washes out of the groundwater plume over time as well. We know that in the city in which I went to school, and in Hanover, we had a case of pollution with CHCs in the 1970s. And again, it was a factory, and you had a plume that went towards the river, and it was found out. The city started drilling wells inside the city area and pumped water out of it in order to make sure that they understood that sort of the water that came out of the groundwater, the contaminated water, was captured, it was cleaned, and it resulted in the plume no longer expanding and eventually actually shrinking. But this is something that takes decades, even for substances that are highly mobile and do not slow down the passage through the underground by adhering to the solid substances.
So you're very engaged in the transatlantic conversation. What does it sound like, feel like here across the river in Washington in terms of receptivity or following or pursuing and studying what's taking place in Brussels on this topic?
PFAS is a mixture of a global problem and a ubiquitous problem. By global problem, I mean that there is a global dynamic causing this, and that is an integrated, globalized chemical industry with chemical processes that sort of sell the same substances into the markets everywhere. And then you have a global system, which is the atmospheric transport that actually distributes the pollution everywhere. So in that sense, it's global. But from a water supplier's perspective, the global aspect is not important. What is important, what is happening in my town. And there we find very similar dynamics in many places, not in every place, but in many places we find the same dynamics of local pollution, either from industrial sources or from diffuse sources. Agricultural application of compost is a diffuse source. And um, uh, um, the solutions that we find in one place for ubiquitous problem, they can usually be transferred to other places. You have to adjust for the legal regime, for the ownership, for the financial capacity, for the technological capacity. But I think in all of those respects, the US and Europe are actually quite similar. Within the US, you have differences. Within Europe, you have differences, but we cover a similar range.
Does anybody wish to ask Andreas a question? I'd be happy to unmute you, or feel free to put a question in the chat box. Andreas is an old friend. We talk a lot. I don't want this to be just a dialogue between me and him.
Hey, keep asking me.
I'm sorry? Oh, here we go. Are you aware of
Yeah.
any forms of public education taking place in Germany or broader EU to engage residents on the issue and
Oh,
promote the
plenty.
purchase use of PFAS-free production products?
Yeah, plenty. In practically all the countries, with differences, the countries with well-developed and well-resourced environmental monitoring systems and environmental administration, all the environmental agencies have websites where they inform about PFAS. Many municipalities do. The city of Rastatt, the case study, they have a website on their own municipal system where you can download brochures. They hire journalists to write briefs, to write reports about all this. And then they have dissemination events in order to make sure that the people in the community talk about it. Environmental NGOs are going to it. So one of the things that they do in Germany is environmental NGOs, they take water samples in every single one of our counties or districts or whatever you call it. And then they do a ranking, and then they publish it, and they send it in copy to all the newspapers, all the local newspapers in all the 470 or so counties that we have in Germany. And with the ranking, you are sure that you're going to get local news coverage across Germany. And that drives a process of interest. And PFAS is really complicated. The chemistry is complicated. The use of PFAS is so widespread in so many products. It's really hard to engage everybody on the totality of the complex of what PFAS is and what we need to do. And so it is always that you have either specialized journalists, or you have NGOs, or you have consumer protection groups, or you have some sort of elite forming around community neighborhood initiatives. They will do that. I do not think that we can expect everybody in the population to keep paying sufficient attention in order to understand the complexity of this issue. But yes, you can. Sorry, Rebecca. You can go and find those websites, and there you find brochures, you find slide decks, you find all sorts of things that serve that purpose.
The next question is, how are you measuring the TFA and what methods are you using?
I don't do that, and I can't really answer that question with a sort of in the terminology of a laboratory technician. So I'm sorry about that one.
And then a question you would expect coming from Northern Virginia. Are there any concerns with PFAS from data center discharge?
There are PFAS that are used in the manufacture of components that you find in data centers. There are PFAS that are used in order to do protection against fire hazards, for example, in cables. And there is firefighting gases and foams that contain PFAS. So there is a concern, but I have not yet seen that come up as a specific problem within Germany. That may be because Germany is behind, Europe is behind the US in the building of data centers.
Any other last questions? Any thoughts to share with our friend? Otherwise, we'll turn everyone loose to finish their lunches. I just want to say, Andreas, thank you so much for taking time from your really busy schedule, staying up so late on a Wednesday evening in Europe to be with us. And I just am so thankful that you were able to do this and look forward perhaps sometime, maybe later this year or next year, doing some kind of follow-up to this because this was super interesting and fascinating. Thank you so much, Andreas.
Thank you, Dale, and thank you, Dale, for all the work that you do connecting people across the Atlantic, because we can learn so much from one another in every direction. So, and thanks everybody for your interest, and hopefully, perhaps one day we can continue the discussion. Thank you.
I know that that's a foregone conclusion. We'll make it happen. Thanks so much. Good night.
Thank you.